Alright, someone who's not a jerk asked me to do this, so I will. Some good person or something. Alright, rectangle has an area of 72 square feet. Draw yourself a rectangle. Area is 72. Okay, scale factor is 6. So now the problem people will run into is they'll see scale factor of 6, they'll take 72, they'll multiply it by 6, they'll get 432, and they'll get the answer wrong. So that's not how scale factor works, right? When we're talking about area, area is in 2 dimensions. So when we talk about scale factor, it has to be affected in 2 dimensions. So when we talked about this, we said that anytime we're doing scale factor, that the new whatever will always be the original amount, right, times the scale factor raised to the number of dimensions, okay, which in this case is 2. So when we work this out, instead of just saying 72 times 6, it's actually going to be 72 times 6 squared. Okay? I don't have a calculator handy. That's like 2,000 something. I'll let you figure that out. All right? The second one, some values for 2 linear equations are shown in the table below. What is the solution? A solution to a system of equations. All a system of equations mean is you have one line going like this, okay, and you have a second line going in a other, more different direction, and the solution to them is where the points meet. So when it gives you 2 tables like this, the solution is just what point do they have in common. So you look at this table, you look at that table, and you pick the point that they have in common. Like if I don't want to just circle it and give away the answer, so let's see who's actually paying attention. Like what if I said 9, -8? In order for that to be the solution, we'd have to have a 9, -8 over here, right? And if that was the case, then you would circle both of them, and you could say the answer is 9, -8. But that's not really the answer. But don't tell anybody. You find your own answer, okay? It's in here. Find the one they have in common. But definitely don't write this answer down, okay? Okay, that's not the answer. All right, number 3. Also, system of linear equations. We just talked about this. Let's go back here. Okay, right? And remember this. If you have, what is it? Different values for the slope. So if we look here, these 2 lines have a different slope, right? One's going down, one's going up. Any 2 lines, if they have different slopes, they will always meet in exactly one place. So our answer for that question is just the number 1. Right? So you would write down 1 as the answer. Okay, make sure you write down the correct answer. Okay. The other possibilities, if they had the same slope, you would end up with a situation kind of like this. You'd have 2 lines heading in the same exact direction, in which case your answer would be there's no solutions. And then every once in a while it gives you one where it's the exact same line, and I realize these aren't the exact same line, but whatever. In that case, there'd be an infinite number of solutions. But if they have different slopes, then the answer is what I told you. Yes. Okay. Classify numbers as rational, whole numbers, or integers. So the key to this is a little chart they probably gave you in like 6th grade. And you might need some room to write this down. There are different sets of numbers. You started with your counting numbers, right? And then you learned about whole numbers, and then you did integers, and then the big one, rational numbers, and then the little one outside, irrational. So let's fill this in here. So you start with the counting. All your counting numbers are, that's like 1, 2, 3, so on forever, right? Just the numbers you count. Then you got whole numbers, which is all of this, 1, 2, 3, so on, so on. You just add the number 0. That's all whole numbers is. It's just this plus 0. Okay? Integers, that's all this, 1, 2, 3, so on, including 0. And then it's the other side to the left of 0. So this has -1 and -2 and -3 and forever. So basically all it is the whole numbers and their opposites. Okay? So technically speaking, there are no negative whole numbers, right? Just integers. But don't be a jerk and like correct people when they say that, unless it's a math test, right? And then our last one are all of our rational numbers, and that's anything you can write as a fraction. So basically this is just everything here, all your positive negative numbers, plus anything that's a fraction or a decimal, because any decimal you can write as a fraction. Okay, and this is most every single number you ever deal with. There's just a couple of off cases that are not rational, which are numbers you can't write as a fraction, which are irrational numbers, and that's like the number pi, and any square root that does not come out nicely. Like square root of 2, you put it in your calculator, it gives you 1.41, whatever. It just goes on forever. Square root of 3 is like 1.8. The square root of 4 we don't include here because the square root of 4, square root of 4 equals 2. And 2 is a counting number, which is a whole number, which is also an integer, which is also a rational number. Right? So when we answer these, we have a rational number because there's a fraction. 1/3 is a fraction, so that's rational. Number 1, you could put counting number, but that's not listed in one of our 4 groups here, so we'd say this is a whole number and also an integer and also rational. Rational. Square root of 85 is not a nice number. You have the square root of 81, which is 9. You have the square root of 100, which is 10. So every square root between 81 and 100 is irrational. The only square roots that are not irrational are ones that happen to work out to exact numbers, in which case you would put whole and integer and rational. So you could probably do this last one. Okay. Label each description as either simple interest or compound. Earning interest on interest, that's compound. Interest payment stays the same. Well, that sounds pretty simple. So that's simple. Number 6, what is the difference between simple and compound interest if you invest that much for 1 year at a rate of 6%? So your two formulas here, I equals PRT for simple, and compound is A equals P times 1 plus R raised to the T power. This doesn't look that great, but you get the idea. But this is actually a special case. It's an interesting question. You could do this work and you'd get an answer, or if you keep in mind, it's exactly 1 year, and we've talked about this. It's that simple and compound interest. At some point in time, compound interest always pays out more, and at some point, simple interest pays out more. And the time that really matters there is 1 year, because at 1 year, simple interest and compound interest work out to the exact same thing. Okay? So when it says what's the difference between simple and compound interest at 1 year, it does not matter what these other two numbers are. The answer is $0. At 1 year, interest between simple and compound, everything else the same, is nothing. Okay? Alright, number 7. This is just a pain, but we can do it. We said anytime you do rotating, every time you move 90 degrees, X and Y switch places. So we're going to start off nice and easy. XY is going to change to Y, comma, X. At 180 degrees, they switch back, so let's go back to being X, comma, Y. At 270, they'll flip again. So from XY, it'll go back to Y and X. And 360 flips one last time to XY again. So the only thing that matters here is what happened to our signs as we went around our grid. So if we draw ourselves a little grid here, we pick some point, doesn't matter where you start, and we're just going to move it 90 degrees clockwise. So we're going from here down to quadrant 4. Okay, so here's our point. We know the order is yx. All that matters is what signs do we need. So you think in quadrant 4, what's true about any point? Well, it's to the right, so x has to be positive, and it's below the line, so y has to be negative. So when we fill in our signs here, right, our x value is going to be positive, and our y value is going to be negative. So we take our x, and wait, hold on. Okay, what are we doing? Okay, so x, our first number is going to be positive, our second number is going to be negative. Okay, excuse me. When we go 190 or 180 degrees, we just go over one more quadrant. X and Y flip back, but in quadrant 3, everything is negative. So instead of xy, it's going to be negative x and negative y, right?
Yep.
Yep. Now you want to come in. Now that we're almost done. Look, we kind of got a happy face going here.
Aw, how cute. It's got eyebrows too.
Yes. That's how you know it's a face. Okay, the last one. Well, second to last one. If we go 270, flip them again. Our signs up here in quadrant 2, x is going to be negative, and now y is positive. So instead of y negative x, now it's negative y and wait, what? Yeah, negative y, positive x. Okay, that's good. And then 360 is the easiest one of the bunch, right? If you go 360 degrees, you just end up right where you started. So xy ends up at xy. Okay? Last two. Alright, this one's pretty good. This is more of an algebra question than anything else. Excuse me. So we have y equals x and y equals negative 3x minus 3. What is the solution? Oh, find the solution first. Okay, so the trick here is that y is equal to one thing, and it's also equal to a second thing. So what you can actually do is say that this thing has to be the same as that thing there. So we're just going to take this, and I'm actually going to do it down here so I have some room to work. So x is going to equal negative 3x minus 3, right? Because they both equal y, so whatever this is the same as that. Now you can throw this in your calculator, do a little menu 3, 1, and end solve that. Or we could actually do the work. We can move the 3x over, so plus 3x plus 3x. This cancels out. This is 4x equals negative 3. I want to get x all by itself, so we divide by 4. And we end up with x equals negative 3/4. Okay, but now we need a y coordinate as well, but this one's nice and easy because it says y equals x, so whatever x is, y is the same thing, so this is just going to be negative 3/4, comma, negative 3/4. And what does that mean? This is the point where our lines intersect. All right, number 10. When an image is dilated, okay, this one's just terrible because there's just blanks everywhere and it's kind of hard to tell. So I'm just going to sort of give you the answers because otherwise, this is a pain. The area of the new image is the product. Oh, that's not the right marker. Product, because anytime you do scale factor, you always multiply, and when you multiply, the answer is a product of the area of the original figure. And then we talked about this up at the very beginning. It's not just the scale factor, but the scale factor to the second power, right? So we say the scale factor squared. And there should be a comma, or a period there. And the second sentence you could probably do, dilation of scale factor greater than, what was the key number? That's 1. What's it called when the scale factor is greater than 1? That's right, it's an enlargement. And a scale factor less than 1 is a reduction. Okay. And let's say the bonus points are for writing down the correct answers. And the people paying attention will know what I'm talking about. Right? And also our rotation face. Okay, good night.